I'm Alice Moore, and as part of the 2023 Knowledge to Know-How Forum, we've dug some soil pits across the road at Main Camp. What we're using these for is basically just to have a look at the soil so we can see the different layers within the soil, so we can see the topsoil versus subsoil. We can have a look at the roots, see how healthy they look, what direction they're actually travelling, whether they're going more horizontal or if they're going vertical. We can have a look at the compaction of the soil, how hard it is, how hard the roots actually have to work to travel through it. We can see, whether it actually needs aerating or if there's any different management tactics that we could be applying to this soil. We're also able to test the pH down the profile for any liming requirements, and we can also have a look at some dispersion tests just to see if there's any sodic layers or magnesic layers that might be causing a problem with the crop. The actual reason that we've done it and that it's useful, you get to have a really good look at the root activity. Firstly, if you can actually find the taproot and identify it, see how far it's going. You can also have a look at the direction of the roots, so if they've sort of hit a layer and then they're sort of travelling horizontal, which you can really see in the other pit as well. Really good indicator, like Lucas was saying this morning, about any subsoil constraints. Compaction layers, so sometimes it will be, depending on the type of soil you have, it'll be really obvious if you've driven a tractor down the roads when it's been a little bit wet. You'll actually end up with like a bit of a bowl of compaction that you can see has come straight from the tractor tyre. In a lot of the soils in the northern rivers, they're usually a clay, but they're usually self-renovating, so they will crack and self-renovate and kind of open back up after that a little bit. What else do you try and see, Terry?
So some of the alluvials are definitely that sort of clay that so as you drive from here to Lismore, a lot of those clays are self-mulching, but a lot of the clay in these duplex profiles isn't quite as friendly as that. It tends to be rubbishy clay.
More kaolinite clay than a smectite clay.
Yeah, and that is where you potentially could get, if you had, I think probably if they were annual crops in a dry season they'd struggle, but you can see the tea tree. And again, the advantage, so dry, those hard, dense subsoils, they're really only problematic when they're dry. It's really hard for anything. So your soil strength goes up and a root, it just can't get through. Whereas when it's really wet, that's why you get compaction when you drive on it. It loses its strength and roots can get through. And that's the advantage for perennials, is even if they spend a year where it's dry and they can't get through, if you hang around for long enough, at some point it gets really wet and they'll get through it. And so I think that's one of the big advantages for tea tree or any other perennial, is that just through longevity, you're going to strike the soil at a weak phase at some point if you hang around, and particularly in the northern rivers, when that soil's inundated, that there's no soil strength, it can get through. So I think as a general rule, even if the tea tree did encounter a sort of hard pan, I think it's going to get through it in the northern rivers, because that soil's going to be really wet at some stage, and even a weak root should be able to get push through that. So and I think you can see there's certainly, I think, Robert, as you said, most of the roots do seem to be in this top 30, but there's still reasonable activity sort of in the next layer down here. And then even, as you said, there's the odd root. Here's one down here. So what's that? It's well over 1 metre. There's a couple poking out here. So it's, again, they don't have those fine ones that are looking for nutrient so much. So the ones up here tend to be, it's with the nutrients that don't move, say phosphorus or zinc or some of those, the root has to find it. It's got to be right next to it and it'll diffuse off the clay to the root. Whereas for other ones, where there's enough of the nutrient in solution, as water moves to roots, those nutrients are dissolved in the water and they'll come to the root. So this guy down here, when it's dry and the water's coming sidewards to that one root, it'll bring nitrate, sulfate, some calcium and some of those elements that are, there's enough in the soil solution to it. So they're still valuable for nutrient uptake, but I guess the main gig for them is water uptake, really. That's what they're there for, and they just happen to pick up anything that comes with the water that flows with it. They'll get for you as well. So
can you just grab a little bit more? I'll do pH as well.
Yep. So from all three.
Yep.
So Terry sampled the soils before. We've got our surface soil here. The water's actually quite clear. It's not particularly dispersive. Went into that grey layer. So you could probably call the grey layer the A horizon. So that top soil would be the A1 horizon, then probably an A horizon. It's slightly dispersive. like a little bit cloudy, but I wouldn't call it dispersive soil. And the clay below it is almost completely non-dispersive, although the clay's falling apart a little bit. Mildly dispersive, but it's very dense. It's very, very clayey. That you could make bricks with that clay subsoil. There's nothing you can do about it as a farmer, really. But just to be aware that it's a very, very high bulk density clay. Probably up around 1.5, 1.6 bulk density, I imagine.
And that's for Australian soils. That's pretty typical to have those.
Yeah.
Clay layer, because we didn't have glaciation, we had no new soil forming processes over the recent thousands of years. Our soils are so old. All that happens is any of the fine clay particles over tens of thousands of years just drift their way down south. They end up down the bottom and you get left with the coarse material at the top. So quite often you'll get profiles with loamy or sandy at the top and these dense clay subsoils, and it's just because our soils are quite old. And these soils aren't old compared to once you head into the rest of Australia, but that's just what happens with soil aging. The clay goes to the bottom, and that's why Lucas showed you those pictures of where they were pulling clay up from the bottom. The problem is their topsoils are in Western Australia, the soils are the oldest in the world.
Yeah. So
they're really, really, really old. So sometimes you just got pure sand. It's all the clay has been leached. Others you got sand, a bit of clay, and like I said, the problem with sand is it's not, as one of the researchers over there says, it's not so much that it's pure sand. The problem is there's actually no clay. So don't blame the sand. The problem is you just need some clay to hold something. So even if they pull up a bit of clay and put it on, all of a sudden you increase your cation exchange capacity so you can hold some nutrients. You can protect some organic matter so you can actually build a bit of organic matter that then holds more nutrients. But when it's just sand, it's very, very hard to build any soil carbon because there's any carbon that goes in that hasn't got a little clay molecule around it, the microbes just, thank you, they eat it. And so I think Robert can give you an example. Do you want to tell? Robert's been mulching for many years, and what's your soil organic matter done there?
Not much. That's really one of those things that needs to go on that board. That's the wicked problem of the south of Casino soils. They've got a low organic matter content, and we put on heaps and heaps and heaps of mulch year after year after year, and virtually none of it gets into the soil, and we've gone from sort of 1 to 1.2% over 20 years of applications of spent leaf.
Yeah.
So the wicked problem really is how do you get it into the soil?
Yeah. So and along exactly the same lines, I've done some, with Terry and others, done some work in the sugarcane industry. Now they're adding roughly 20 tonnes of dry matter, with the trash harvest per year onto some of these sites, both in Queensland and locally here as well. And their soil organic carbon content is still going down. So a reason for that, and I mentioned it briefly in the talk before, was that sugarcane trash, that leaf content, it's got a carbon to nitrogen ratio of between 50 and 100 to 1. So it goes into the soil, the microbes see it like we would see white bread. Now, energy source, but not a lot of nutrient for building muscle. And that's exactly the same thing with your organic carbon inputs. They need the nitrogen to go with it, they need the protein content. So what the microbes do, they break down the mulch, turn it back into CO2, goes up into the atmosphere, and they also break down the soil organic matter that's been stored to access the nitrogen for their own metabolic activity. So you're actually getting a decrease in soil organic matter even when you're adding 20 tonnes of mulch per year. We've got all the, we've done all the scientific tests on exactly why that is the case with stable isotope methodologies. So yeah, the quality of the carbon going into the soil, the quality of the mulch going into the soil will play a big role in whether or not you actually decrease the carbon content, or in your case, Robert, increase it even though it's only slight. I think it's probably because your quality of carbon is higher than, say, just like a cane trash, for example.
Have we only got one type of microbe if we just use one type of mulch?
That's a good question. You probably start restricting the population. The more complex the carbon goes in, the more complex the population will be. So if you add white bread, you'll really just sort of limit your population to people that like white bread. If you have a smorgasbord of different carbons there, you definitely maximise your population. And you tend to have, when you add the more complex carbons, you tend to go for the more long-term microbes. So the microbes that like boom and bust, they're called the R strategists, will flourish if you add a simple carbon like glucose or simple carbohydrate. If you add a complex carbon like a compost, biochar, probably even tea tree mulch will fit into that category, you probably get a lot more fungal activity, things that will hang around a lot longer and will do other things in soil. And the fungi are really important as well for building soil structure. So they tend to have glues, make glues like glomalin. You might have heard of glomalin. They tend to make those glues, which helps in the aggregation process. So having those fungi in the soil are actually quite important.
But tea tree mulch, for example, if you're just throwing out your tea tree mulch, you get a bit of both. So the leaf is pretty easy to decompose and feeds one particular or group. So it's not just one microbe. There's thousands, if not millions. But you also get the woody material. So you probably are going to have. It'll take fungi to get rid of those ones. So it's not a bad substrate by itself. But yeah, if you just hit it with the same stuff each year, you'll select for microbial populations that like breaking down that stuff. That's just same as your gut. If you eat a certain thing, you'll be able to break it down. Whereas if you haven't eaten something before and you have it and your stomach doesn't like it, it's going to struggle. So.
But yeah, you definitely want to diversify your carbon inputs as much as you possibly can, be it through adding stuff or growing intercrops or cover crops in your system, or through rotation, which is not really an option here. But I think the intercropping is definitely something that Terry's done work on, and has got a lot of work in the soil CRC.
But it's much easier. That's the thing. In an annual cropping system, you can rotate crops. You can grow all sorts. And even in sugarcane, after 8 years of ratooning, you can switch out, grow some beans. If you want, you can grow anything. It's harder in tea tree. It really is the world's greatest monoculture. Yeah, I don't know of any other crop other than a forestry plantation, that has a monoculture for that long, and that's where it gets tricky. How do you get diverse sources of carbon into soils? And we've tried a couple of times to after harvest plant something. We tried with legumes and a few other things, and I think Alistair was telling me they've planted some radish this year in amongst it. But it's a tricky one, because you've got to have moisture to get them up, and then you've got your weed control. And so it also depends on your tolerance to letting a few weeds grow before you might want to take them out. So if you're very anal about weed control, trying to grow anything else in there is probably not the best. Whereas if you're a bit more lax and think, okay, well I can handle a bit there, I'll get rid of them later. That's really the only chance, I think, is in that time after harvest, if you did want to get something in. It's just tricky, that one, because you've got a million other things going on, and two, you need the rainfall to be right, and you need to fit it in with your herbicide. So open to any idea. I mean, Robert, you're one of the few people I know who've tried it. What are the challenges you see, and do you think that there's any chance for it, or is it just pie in the sky?
Yeah, there's a chance, and we're giving it a go this year, not for various reasons. But yeah, the weed control thing's the difficult one. It was a mixture of tillage radish and some rocket. I don't think the rockets come up all that well, probably because we planted it through a thick mulch layer and it probably went in a bit deep.
Yeah.
But I'm hoping for a bit of rain and we might sort of get an improvement in the strike. But yeah, pre-emergent herbicides, usually we like to get right on top of the weeds at the time of harvest. At this time of year, if anything wants to go, it'll really go and move quickly and possibly get out of control. So we're sort of keen on the pre-emergence, but can you use any of the broadleaf pre-emergent herbicides and plant a brassica? No, I think the short answer to that is pretty risky. In which case we're leaving ourselves open to sort of post-emergence control of a whole lot of junk broadleaves, which are not necessarily all that simple to control.
Yeah. It's certainly, we tried a couple of spring sows for people who are harvesting in spring. That got tricky because you get it harvested, and then you probably want one strike at the weeds before you sow, and then spring rainfall around here is as dicey as, and so you got to jag a bit of rain at the right time. It was really tricky. Whereas probably one of the best success we had was actually at main camp. That was probably about 7 or 8 years ago, because you guys were harvesting earlier. Winter was a lot better, where you get because the tea tree was slow to come back, you had a bigger window before it shades everything out, and that opened up. There was a heap of winter legumes we could try, favour all the pulses, that could go in, but it was then, so we could get them, and also it was wet. You know, you didn't have that sort of hot weather and lack of rainfall, so you could grow them. But it was just fitting it in with all the other jobs you got on at that time was the reason we sort of never, at the time, look, it's interesting, but it's just too tricky. But certainly that opportunity in winter seemed like the easiest agronomically, as opposed to, like you say, in summer the tea tree's up and going, but your weeds are going to go ballistic, and spring just the rainfall seems to be so unpredictable. So that was our main challenge there.
With a cover crop, you can't even, if you get a big strike of weeds, you can't even put the bloody cattle in there. You know, a lot of those weeds are quite palatable and nutritious. Ragweed's quite palatable and quite nutritious to our cattle anyway. We've got them well trained.
But there's so too of the brassicas.
Yeah, that's right. So you can't put the cattle in because you've got the brassicas, and they'll just eat the brassicas out
and leave your weeds. Yeah.
So, you know, all of those weed control techniques are just not available. So you've really got to let the whole lot rip until you're prepared to
take them out.
Yeah.
Yep. And that's it, and so it's risky, and it depends on, you know, if you really get nervous about seeing weeds and you can't hack it, it's definitely not going to work. If you're sort of a bit more open-minded, okay, they're weeds, I'll keep them in check at some point, let them get a bit on them. But again, then you've got to be able to get it when you want to get them out. You know, you've got to be able to get on. So it's just inherently challenging in a system like this. I mean, you get you're always going to have weeds, like, so you do have some diversity going in, bit of nut grass and bits of weeds, but it's not the same as in other systems where you can rotate out, or a pasture where you can just have, you know, 5 or 6 grasses or legumes that you want, plus whatever other random things just come up. It's just tea trees. It's a very tricky monoculture.
Terry, Alice has just done the pH test, so I guess the good news is your surface soil. So these are like just store purchased pH test kits, and they don't replace a lab test. But in water, your surface soil looks quite good. Sort of pH, I don't know, 6, 5.5 to 6.
Yep.
And even that sort of grey layer, that sort of A2 horizon, is sitting at maybe 5.5 to 6, sort of in that range. I would say that's quite good. The clay, the yellow stuff, as soon as you hit that yellow layer, that will be down at, I would say, 4.5 in water, which could be actually lower in calcium chloride. But so I wouldn't be surprised if they're probably starting to be some aluminium issues at depth right there, and that could be a reason why maybe there's not much root penetration to depth. 2 reasons. One is it's actually a really high bulk density clay. Not much you can do about that in the field, but yeah, you do have some subsoil acidity there.
The only thing I will say though is, yes, tea tree evolved here, and where's Merv? We've, you know, those sites where you've collected from in the swamps and up at Stanthorpe for the genetic diversity, they were acid soils, weren't they?
Completely different. One's like chewing gum, the devil's pulpit is, it's like plasticine, whereas Stanthorpe is granite sand.
But again, low pH, and I think so that they obviously tolerate it.
Yeah.
And again, so even with liming, you say, what's the optimum pH for tea tree? Well, one, we don't know, but it clearly doesn't mind acid soils. It evolved here and it's down there in pH 4.5. But certainly for the topsoil, regardless of whether tea tree likes it, we know that soil microbes, your nutrient turnover, all that sort of jazz, it works best at 5.5 and above. So you're still probably better off keeping your topsoil in that range just to keep basically your soil biology functioning. But in terms of what pH does tea tree function optimally at, my guess is it's quite happy in reasonably acid soils because that's where it's evolved. All those sites that we checked with you, Merv, they were acid soils, and that's where it's growing and has come from. So, and again, its roots are down there. I know high aluminium is pretty typical of the North Coast in your subsoils. It's down there, and again, there's not much you can do about it, unfortunately.
But you got 60 centimetres of really good soil, I reckon. So
up above it.
Yeah.
Yep.
So Terry, those deep roots, they're just fibrous roots that have come down from the root crown rather than off the taproot, or how far do you think the taproot is?
I have no idea. Shall I try and track one? Yeah, we might struggle.
You'll never get
That's-
that, Terry.
My guess would I'm guessing that's come off a taproot. Like, I'm guessing it's. But you can look. There's not a fine root on it. Like, there's not a fine. There won't be even if we put it on the mic, there won't be root hairs.
That's probably not taking up much nutrient or water. It'll be
It'll
taking
take
up
up.
some,
Yeah.
but not like the fibrous roots.
No, but it'll take up.
Some of the taproots or stumps I ploughed out at, 3 foot of taproot
Straight down.
went down from, big down to just a point.
Yep.
Of, 3 foot deep.
Yep.
900 hole long.
Yeah, so they clearly get there. Yeah, and again, it's just that sort of root. It's not chasing you. It's one stability, but also water. Like that they're still down there plucking out water, and that's why you'll still get any nitrate that's down there that's leached. Like, nitrogen's a slippery devil. Luke was talking before. Basically, you usually assume in most scenarios, if you put on 100 kilos of urea, so that's 50 kilos of nitrogen, say, your crop might get 25 to 30. The rest of it is, some of it, some's lost up, but mostly we leach it. It's just the nature of the beast. Once it turns into nitrate, it just moves so quickly. The advantage here is if you've got roots down to 2 metres, even if it's washing out, all it takes is a root down there, because it's dissolved in the water.
It'll take it
It'll
up
take it.
automatically with the water.
And I actually think, and we did some nitrous oxide work, which is a gas that goes off, and tea tree had pretty low nitrous oxide emissions. And a lot of the reason we think that is because you've got roots set in place. So in other systems where you're planting an annual, you put fertiliser on, it all turns to nitrate, which can then go off as a gas, and the roots have then got to quickly catch it, get some biomass and drive plant growth. You've already got a plant there that's hungry, you've got a root system in place, so it can take up a lot of that nitrogen pretty quickly. So my guess would be, and again, we haven't got any data to prove it, because you've got roots down there and you've got a hungry plant ready to go straight after harvest, is that our nitrogen use efficiency is higher. So I don't think we would be losing 50% of what we apply. I think we'd be capturing a lot more, just because we've got roots at depth to pick up anything that leaches, and we've got a plant that's already there, and particularly if you're harvesting late when there's heat and it's trying to grow, it'll be wanting to suck it up. So again, we don't have any exact number, but my guess is we probably capture a reasonable amount of our nitrogen if we put it in the ground. If you throw manure on the surface, as soon as you get a breeze and you can smell ammonia, you know that a lot of it's volatilising. So but if you can get it in the ground, I think there's a fair chance that we're not losing too much at all. So that's another bonus of having a tree with roots down that deep.